So let's look at 83Q, integration by parts. This one's a little bit different than integration by parts, where we get a simpler integral. We'll see that we don't get a simpler integral. We get one that is basically the same level of difficulty. But what happens is by using integration by parts twice, we get back to this original integral, and we can then solve for this integral by solving like an equation. And so I've done one like this in the lecture video. This one is very similar to that. So again, here it is, e to the 2x sine of 4x. What's the antiderivative? Okay, so we are multiplying, right? E to the 2x function times sine of 4x function. So we've got a product here. It makes sense to think about integration by parts. Now, choosing u, we have the Liate acronym, log. There's no log, no inverse trig. There's no algebraic. I mean, there's a 4x and 2x, but they're inside a trig and exponential. And so TE stands for trig, and then E for exponential. Those are at the low end of the spectrum. You could choose u then to be either the trig function, the sine, or the exponential. I'm going to do the trig function just because T comes before E in this saying, but both will work in this case. It doesn't really matter. The sine and the trig functions, the sine in this case, and the exponential functions are bad choices for you in general, but we'll see that this will indeed work out in this case. So I'm going to let u be the sine of 4x, and the dv therefore is e to the 2x dx. So here I take the derivative. So you have to remember the chain rule, right? Got the outer function is sine, inner function is 4x. So it's the derivative of the outer function, which is cosine, evaluated the inner function 4x, times the derivative of the inner function times 4x, which is 4. Right, so I've got 4, the derivative of 4x is 4 times the derivative of the outer function cosine evaluated at 4x. So it's 4 times cosine of 4x. And don't forget our dx. So there's the du. Now integrating e to the 2x, well, the antiderivative is not e to the 2x, because if I take the derivative of e to the 2x, I get what? By the chain rule we just used up above, I get 2 times e to the 2x. So I need a factor of 1/2, right? You can integrate both sides and do it formally by doing a substitution where you let, say, w equal 2x, and then dw is what? 2 dx, therefore 1/2 dw is dx. That's where the 1/2 comes from. Okay, so you should make sure you're very careful on this. Sometimes you have a little substitution to do a lot of times in the integration by parts. Okay, so now we're ready to plug into the integration by parts. Integral of u dv is uv minus v du. So u was the sine of 4x, v was 1/2 e to the 2x. Got those multiplied together. Here I got v times u, doesn't matter the order we multiply them in. And then v du. So what I've done is v du, I've got a 4 times 1/2. 4 times 1/2 is 2. I bought that 2 out, and I'm left with e to the 2x times cosine of 4x, right? And so here's my resulting integral here. And you can see it's at the same level of complexity. They both have e to the 2x, and one's sine, one's cosine of 4x. I mean, the original integral in this one are equally as challenging to do. And so it seems like we're not getting a simpler integral. But in this case, if we choose integration by parts again on this one, what am I going to do? I'm going to let u again be the trig function cosine of 4x. So du is -4 sine of 4x. Remember, the derivative of cosine is negative, right, sine. So there's where the negative comes from. And it does get a little tricky in here because sometimes you're integrating, sometimes you're differentiating, and dealing with sine and cosine and which one's positive, which one's negative is tricky. So you want to make sure that you have a way of remembering that and being able to bring that up. And it's not just memorization, but you can actually, think about the relationship between these functions and their derivatives. Okay, and I can help you with that if you want to meet with me separately to discuss. dv again is e to the 2x dx, antiderivative as before. And so I'm going to rewrite the integral we're talking about is, this thing -2. I pull the 2 out, and then this integral becomes uv minus v du. So u is cosine of 4x. V is 1/2 e to the 2x. So there's the UV, but then it's minus, where's this plus coming from? Well, minus integral V du, minus V du. Notice the negative here, -1, -4 rather, times 1/2 is -2. -4 times 1/2 is -2. And a -2 is a +2. So that's what happened there. Right? It's normally minus the integral V du, but since we have a -2 factor that comes out, -1 times -2 gives me +2. And we're left with then e to the 2x sine of 4x dx. And you'll notice then what I've done is here's our integral that we started with, e to the 2x times sine of 4x. And here it is again. We're right back where we started from. You might say, well, we've got nowhere, but we actually have, because I have an equation now. If I just call this integral I'm looking for I, this is I, and then clean this up. So I got I is equal to, again, this stuff. And then this -2 here, I want to distribute through. -2 times 1/2 is -1 e to the 2x cosine of 4x. -2 times +2 is -4 times this integral that I'm calling I. So now I have an equation that I can solve for I. I add 4i to both sides. I plus 4i is 5i. All right. And then I can divide by 5 or multiply by 1/5. So if I multiply this thing, put that in the parentheses by 1/5, 1/5 times 1/2 is 1/10. All right. E to the 2x sine of 4x. 1/5 times -1 is -1/5 e to the 2x cosine of 4x. And then I'll go ahead and put plus c. This is the answer. This is the answer right here. Okay. Now I did the answer that I have in my answers looks like this. So it doesn't matter. I'll take either one. I factored out a 1/10 e to the 2x from both of these. Factoring out a 1/10 e to the 2x leaves the sine of 4x here. And factoring out a 1/10 from a 1/5 leaves 2, right? 2/10 is 1/5. So just clean it up a little bit. But there is the end result. And I hope this makes sense. So you do have a lot to keep track of. And you can see how long this problem was, one complete sheet of paper, right? And a lot of these problems you'll begin to notice are that way.